Hi, this set of notes is about partial pressure. As usual, there's a set of notes in Schoology for you to use, or you may take your own. All right, so when we talked about the different gas laws and the ideal gas law and the combined gas law, we've always been talking about just pure gases and not mixtures of gases. And so there's one particular law or one particular idea in chemistry that governs the idea of when you put a mixture of gases together, and that's Dalton's law of partial pressures. And basically it says the total pressure of a mixture of gases equals the sum of the pressures that they would exert if they were present alone. So the total pressure is the pressure of each of the species of gas in a particular situation. So down here in our diagram, there's oxygen that has, in this container, that has a pressure of 159 millimeters of mercury. We have nitrogen in this one. This one has a 593 millimeters of mercury. If we put those into the same vessel, then the overall pressure of them together is going to equal the two pressures added together. This is a pretty simple concept, but it has some interesting applications. One such application is the idea of mole fraction. And so this is basically just thinking about if you wanted to figure out the various amount of pressure or the proportion of pressure in a particular vessel at any particular time, it is going to be related to the number of moles of that of gas inside the vessel. So because each gas in the mixture behaves independently, the proportion of moles in each gas is related to its partial pressure. So the pressure of gas 1 as a fraction of the total pressure is directly related to the number of moles of that gas divided by the total number of moles. Okay, so that number then, the number of moles of the gas divided by the total number of moles, is called the mole fraction, and we can then use it to figure out the pressure of any gas if we know the total pressure and we know how many moles or the mole fraction of that particular gas in the vessel. The last thing that this is related to as well is this idea of collecting gases over water. We did this recently in our molar volume of gas lab that we recently did. But basically, any time that you have a reaction going that develops a gas, you can go ahead and bubble that gas into a container that's completely full of water, and that will push the water out and collect the gas up on top. Okay, so we refer to this as collecting gas over water. We did this in our lab, of course, with our big tall udiometer. When you do this, there's two adjustments that have to be made in order for you to accurately make measurements with it. The first thing is that when you complete collecting that gas, the container has to be raised or lowered so that the water level inside the container equals the water level outside the container. Right, so we put that in there, and we make it so that those two things are equal, and then you can read the value. Okay, the reason why we do this is by doing that, you ensure that the value or that the pressure inside the vessel is the same as the atmospheric pressure outside. If there's a difference in levels, there's a difference in the pressures between the two of them. So by having those two water levels equal, you make sure that you know what the pressure of the gas inside is because you've equalized it with the atmospheric pressure. The other adjustment that we have to make is that if we're collecting over water, that means that there will necessarily be some water vapor in our container. Okay, water that we're collecting over the top of will spontaneously evaporate as this is going on in small amounts. And so as it does that, that creates water vapor gas particles that contribute pressure to the overall pressure. So upon completion, there's water vapor evaporating from water evaporating that's mixed in with the gas. That has a partial pressure. So again, to find the pressure only for the desired gas, you have to subtract the vapor pressure of the water from the total pressure. Okay, the vapor pressure of water varies depending upon different temperatures, and so if that's the case, you are given a table to do that thing. That's it. With this information, you should be able to complete most, if not all of your lab, and as well as going ahead and making sure that you're finishing up these notes. Have a great day. Bye.